Welcome, class. Today in JSS 2 Basic Technology, we are studying concrete, one of the most important construction materials in Nigeria and the world. You will learn what concrete is made of, how it is mixed, and why it is so widely used. Concrete is a composite building material made by mixing cement, sand, gravel or crushed stone, and water together. When this mixture sets and hardens, it becomes an extremely strong, stone-like material. Concrete is the most widely used construction material in the world today. In Nigeria, concrete is used to build everything from the foundations of houses to roads, bridges, dams, office towers, and jetties on the coast. Walk through any Nigerian town or city and concrete is everywhere, in buildings, pavements, culverts, and walls. Let us study the ingredients of concrete. Cement is the binding agent, the material that holds everything together. When cement is mixed with water, a chemical reaction called hydration begins. The cement paste gradually hardens and stiffens, bonding the other ingredients into solid concrete. The most commonly used cement is Portland cement, which is the grey powdery material sold in bags at building materials shops across Nigeria. Nigerian cement manufacturers include Dangote Cement, Lafarge, and BECE cement. Fine aggregate, which is sand, provides bulk to the concrete and fills the gaps between the coarse aggregate particles. The sand must be clean, it should not contain clay, silt, or organic matter, as these weaken the concrete. River sand and sharp sand are commonly used. Coarse aggregate, which is gravel or crushed granite stone, makes up the largest part of the concrete mix by volume. The stones provide the strength backbone of the concrete. In many parts of Nigeria, locally quarried granite is used as coarse aggregate. Water activates the hydration reaction in the cement. The water used must be clean and free from chemicals, salt, or organic matter that could interfere with the hardening process. Seawater should never be used for concrete because the salt attacks the steel reinforcement. Additives and admixtures are sometimes added to concrete to improve specific properties. Plasticizers make the concrete more fluid and easier to pour without adding extra water. Retarders slow down the hardening process, giving workers more time to place the concrete. Accelerators speed up hardening, useful when quick strength is needed. Waterproofers help the concrete resist water penetration. The concrete mix ratio is the proportion of cement, sand, and gravel used. The ratio is written as cement to sand to gravel. For example, a mix ratio of 1:2:4 means 1 part cement, 2 parts sand, 4 parts gravel. This is a relatively lean mix used for general mass concrete work. A mix ratio of 1:1.5:3 is a stronger mix used for reinforced concrete structures like beams and columns. A mix ratio of 1:3:6 is a weak mix used for blinding, a thin layer of concrete laid on the ground before reinforced foundations. The water-cement ratio is very important. Too much water makes the concrete weak and porous. Too little water makes it difficult to mix and place. The right amount of water gives a workable mix that produces strong, durable concrete. Concrete making process: first, measure out the correct proportions of cement, sand, and aggregate. Then mix the dry materials together until they are evenly blended. Add water gradually while mixing. Continue mixing until the concrete is uniform in color and consistency. Then place the concrete immediately into formwork, the mold that gives the concrete its shape. Curing is the process of keeping the concrete moist for several days after it is placed, to allow the hardening reaction to continue properly. Concrete is typically covered with wet sacking, plastic sheeting, or sprayed with water for at least 7 days. Proper curing significantly increases the final strength of the concrete. Reinforced concrete combines the compressive strength of concrete with the tensile strength of steel. Steel reinforcement bars, called rebar, are embedded in the concrete before it hardens. The concrete resists compression forces, the squeezing forces in a beam or column, while the steel resists tension, the pulling forces. Reinforced concrete is used for beams, columns, slabs, foundations, and bridges. Plain concrete without reinforcement is used for mass concrete work such as foundations below ground, road bases, and pathways where tensile forces are not critical. Precast concrete elements are made in a factory under controlled conditions and then transported to the construction site. Examples include precast concrete blocks, lintels above doors and windows, drainage pipes, and fence posts. Precast concrete is stronger and more consistent than site mixed concrete. Properties of concrete include high compressive strength, durability, fire resistance, and low maintenance. Its main weakness is low tensile strength, which is overcome by reinforcement. As future technologists, understanding concrete helps you participate in the construction industry, which is one of the fastest growing sectors of the Nigerian economy.